approach to this talk. Do I have anybody that's not writing code? So, couple roles, product managers. Okay. Okay. So I hope you all get value. I hope you all enjoy the session. I'd like to start off this session with an experience I had a couple of years ago. Now, the experience starts with me traveling to the US to attend a regional conference. And something I love doing when I travel is a thing called team tourism. So the idea behind team tourism is that there are teams all over the world that are doing brilliant things. And if you just spend a bit of time with those teams to do the work with them, you uncover these things that they're doing, and you can bring that back to your own team. And you'll be amazed at what impact that can have on how you do your own work. So in this instance, I was traveling to the US, to Utah, and there's a company in Utah called Pluralsight. Now, Pluralsight has a strong focus on software craftsmanship. In fact, their focus is so strong on software craftsmanship, if you get employed by them as a developer, on your payslip, it says software craftsman. So I had an expectation by setting this up, knowing of the practices that they embrace. My expectation was I was going to spend a day pairing with a developer, writing code. So imagine my surprise when I arrived there on the day and the team I'm going to spend the day with tells me that they're not going to do pair programming. They do this thing called mob programming. Well, I had no idea what mob programming was. But after spending a day with them, I not only discovered a unique way of tackling work, I also found a very, very enjoyable way of learning and growing as a software developer. And that's really what I want to focus on today, is the practice of mob programming. So just by way of introduction, my name is Mark Pearl. I'm a dev lead for MYB based in Auckland. I've been in New Zealand for 8 months, originally from South Africa. And if you find some of the topics I shared today interesting, I share a lot of this on Twitter, the ideas, and on my blog. And I'd love to engage with you on those two platforms. So I want to start off by framing the session with a quote. And the quote comes from organizational behaviorist Peter Block. And he says, "The value of another's experience is to give us hope, not to tell us how or whether to proceed. I'm not here to tell you that you have to do mob programming or that this is the only way you can do it. But I am here to give you hope that if this is something you'd like to try, that it is possible and that teams are succeeding with it." Now, I've had several years of experience with mob programming, and it can be tough getting started. And in an attempt to make it easier for other teams trying this practice, I've put some of the common mistakes that we made mobbing into a book. It is by no means complete, but my hopes is that if you are going to try these things, that this can help you avoid some of the mistakes we've made in the past. It's also the best book I've ever written in my life. Never thought I'd be able to say that. And just an outline of what I'm going to cover today. I'm going to talk about what mob programming is. I'm going to walk you through the roles and mechanics. And then I'm going to move on to some of the more interesting things, common questions we get around it, and the things that we've learned in applying it. So what is mob programming? Well, at a very basic level, it's when 3 or more people get together to solve a single problem at a single computer. That's it. And while this may sound like a radical idea, it's not as radical as you may think. There are teams all over the world that are seeing benefits from applying this practice. And in going into the mechanics of mob programming, I need to talk a bit about the origins of it. So mob programming, while it's not seen as a practice of extreme programming, it really is an evolutionary step forward from many of the practices of extreme programming. And one of the foundational practices in extreme programming is this concept of pair programming. And in pair programming, you have 2 roles. You have the role of a driver and the role of a navigator. And the idea is that 2 people are sitting in front of a computer. The driver is the person behind the keyboard, and they're really typing the code in, solving the problem now. The navigator is looking where the driver is going and looking for areas of improvement, trying to see a little further than where the driver is seeing. And while that metaphor works really, really well in pair programming, I'm on a mission to change the roles in mob programming, because the idea of having multiple navigators with one driver just seems really, really broken. So I've renamed the roles to typist and rest of the mob. How's that for a metaphor? Does that work? If you struggle, like when I say typist or rest of the mob, just replace that with driver and navigator in your mind if you're someone practicing pair programming. So what does the typist do? I've brought it down to three things. First of all, the typist needs to listen to what the mob is asking him to do. They need to then translate that into code, and they need to be able to work with an incomplete understanding for short periods of time. So listening to what a mob is asking you to do can be tough, especially when the mob has absolutely no clue what they want you to do. And at times like that, if you're the typist, you've got to be patient. You've got to take a deep breath. Your goal is to get the mob to work together. Once you start having direction, you then need to be able to translate what the mob is asking you to do into code. And you'll see I've put in brackets there saying don't prematurely challenge things. So something that I found with when I was studying with mob programming and I was the typist, I would be behind the keyboard and the mob would say, okay, we're going to do this. And wait. Like, there's a better approach here. Why don't we do this? And I found that we would go into these endless discussions on approaches and stuff like that until somebody said, why don't you change your approach? Just write the code. And then once the code's on the screen, then we can talk about it. And after changing my approach to that, I found that a lot of the discussions that we had that went nowhere just fell away because we had an artifact in front of us. And I think it really is one of two reasons. Either what the mob was asking us to do, asking me to do, and what I wanted to do were probably the same thing. We just didn't realize it because we were using different words. And once we got to seeing code, we could bring those concepts back together. Or, and quite possibly, the mob had a different approach. And I just wasn't seeing that that approach was a valid approach. And once I'd written out the code, I could see, okay, this is going in a direction that we can go. So you don't want to prematurely challenge things, and a good indication that you're ready to actually challenge the design is once the code is on the screen. Finally, you need to be able to work with an incomplete understanding for short periods of time. And I've underlined and put in bold short periods of time. It's really important that you don't prematurely challenge things. But for you to be effective in mob programming, you need to realize that you're only going to be the typist for a very small portion of the time that you're in the mob. Most of the time, you're going to be part of the rest of the mob. And for you to be effective in that, you need to understand what approaches you're taking. So once the code is on the screen, if you're the typist and you still don't understand where you're going, you need to make sure that the rest of the mob explains it to you. So when you move out into the rest of the mob, you can carry on adding value. So that's really the typist. Well, the rest of the mob also has three main roles. They need to help discover what the next logical step is, talk at appropriate levels of abstraction, and then always try to increase this level of understanding of the mob. So help discover what the next logical step is. You'll see lots of different directions, especially if you're in a new mob where you're not really in sync with everybody else. You might want to go in multiple places. And really, as part of the rest of the mob, you need to work collaboratively to identify what is the next step we want to take and park off everything else. Just put it on the side. You also need to talk at appropriate levels. So what does it mean to talk at an appropriate level of abstraction? I think a classic example is when you're talking to the typist. If I'm dealing with a typist that is relatively inexperienced, I'm going to talk at a totally different level than if I am talking to somebody that is very experienced and that we're in sync with. So let's say I see an extract method into a new class. If I'm in sync with that person, I might just say, let's extract that method and put it into a new class. if I see that that person isn't understanding, I will move my level of granularity to make it a lot clearer. So move to line 145, highlight the next 5 lines, right-click, select extract method, and put it into the class. See, the level of abstraction is adjusting. And figuring out the right level of abstraction can be tough. That's half the challenge of learning to communicate. While dealing with the typist is kind of an easy way to explain it, you also need to be aware of everybody else and be aware of the people that are in the mob. A common question I get is, who can be in the mob? Is it just programmers? And I think that that isn't necessarily the case. You can have multiple people in the mob, and you need to be aware of what they understand and what levels of abstraction they can work at. And then finally, you always need to try and increase levels of understanding in the mob. That means if you're part of the rest of the mob, and you think that somebody in your mob doesn't really understand what's going on, it's part of your responsibility to, in a safe way, identify that and help them get to a point where they understand it. And the converse applies as well. If you don't understand what's going on, you need to have enough courage to ask for people to explain it to you. And if you do that, you'll find that a lot of the issues in mob programming just fall away because you're continually getting everybody up to speed. So we've gone through the typist and the rest of the mob. Well, dealing with people can be tough. And Woody Zuhl, who I consider really the father of mob programming, has this protocol that he says you should apply when dealing in the mob. He says, always treat people with kindness, consideration, and respect. Well, those 3 attributes are all important. The one that I would really like to focus on is the attribute of consideration. What does it mean to truly consider those around you? For me, it means to listen, to really listen and put yourself in their place and try and understand where they're coming from. If you get that right, you're going to move miles and miles ahead of anybody else. Another saying that I like is one from Llewellyn Falco. Now, Llewellyn Falco and Woody Zuhl worked really early together when mob probing was emerging as more of a formal practice. And Llewellyn Falco has this mantra where he says, for an idea to go from someone's head into the computer, it must go through someone else's hands first. Now, he came up with this phrase when he wrote a blog post, I think it was around 2006, on strong style pairing, but it applies to mob probing just as well. If you have an idea, it first needs to go through somebody else's hands before it gets into the computer. So how does that look? Well, I've got a quick animation of how mob probing looks. Normally you'll have some sort of timer up front. And that time will be timing and set intervals, and somebody will be the typist with the keyboard. When that time runs out, you rotate the keyboard, it moves to the next person, while everybody's communicating with that person to try and get the problem solved. So it looks really simple. How does that look in real life? Well, it just so happens in my previous team, we did a recording of us doing mob programming. And this is our average day. So first of all, what you don't see in this picture is there's a big 60-inch screen in front of us with a little screen to the side with a timer. And you'll notice that we have a set of keyboards. All these keyboards are going into a single computer. It's just we happen to be very particular on the types of keyboards we like. Please notice who has the coolest keyboard there. You also notice that I've outlined in red who's currently typing on the keyboard. Just see, it's very organic. That keyboard is moving around. People are engaged. You also notice that we have people that randomly walk up to the mob that aren't necessarily part of the team. The beautiful thing when you make code visible to everybody is it becomes a discussion point, and you can get lots of insights from people around you. So one of the things you'll notice there is we have a whiteboard. And that whiteboard is really important for us. What we're doing is, as a mob, we're identifying things. We might pick out something that we think is important, but we don't want to solve it right now. We'll just park it on the whiteboard, and we'll come back to it at a later point. So that's our way of working. You also notice we have our team board right there. It's got our work on it. We're very aware of what's going on. And our product owner is sitting right by us. He's in the background there behind us. He's available to answer any questions that we have. Something else we've also noticed about mob programming is you tend to have lunch breaks at the same time. It just makes it easier getting in sync afterwards. And we're engaged the whole time. Like, people are consistently looking at the screen, engaging with the problem. Now, this way of working is extremely tiring. By the end of a day like this, I am drained. But I've also written some of the best code I've ever written in my life in this way of working. It's an extremely enjoyable way of working together. That's enough of what our typical day looks like. There are two situations I found where that kind of standard mechanics of mob programming doesn't work very well. And the first is when there's only one person in the mob that's an expert. Well, turns out that when only one person knows what's going on, it's a bad idea to give that person the keyboard. They just start shooting way faster than anybody else can follow. And so we have a rule. If we've identified an expert in the mob for a specific problem, they're not allowed to rotate into the typist role. They've got to stand back and really just increase the understanding. What we're trying to get from that is we're trying to reduce key man dependencies. We're trying to get this cross-knowledge share. So if you identify somebody in your mob that's an expert, get them to stand back, get them to help everybody else in the mob get up to speed. The other situation that we have is what do you do when nobody knows what's going on? Well, there are really one of two things that cause this. I think the first cause of this is if the code is really, really complex. Quite often, we might be working on a legacy system where nobody has a clue, and the person that wrote that code is long gone. And it's highly complex stuff. It's just a mess. And we want to get to the bottom of it. So we use a technique where we call a throwaway refactor. But what we'll do is we'll identify a time box period, maybe 20 minutes. And in those 20 minutes, we make a commit in our code before we start. And then we very aggressively refactor the code to try and extract and reduce the complexity. We're not going to worry about it being a safe refactor. Like, we're going to try and keep the refactoring safe, but if we can't, well, that doesn't really matter. At the end of the 20 minutes, we stop. We talk about what we've uncovered, and then we throw away those changes totally. We just reset it. And then we restart again. But now we go very slowly, very safely. And we found that in doing this, it reduces the complexity quite a bit, and we're able to extract these concepts without having a lot of confusion going on. The other scenario that often causes nobody to know what's going on in the mob is when you're dealing with a new framework or technology where just nobody has had exposure to. And there's no real essential complexity in the thing. Like, give me an hour and a few tutorials and I'll understand this, but I just haven't had that exposure up to this point. So in situations like that, we'll do a time box separation. And really, the point of the time box separation is just to give us each an opportunity to apply our own learning style to understand that framework or that technology. And we'll identify what do we need to know to move forward as a mob. And then the rule is quite simple. You go off on your own. You use all the tools available to you. If you want to Google, if you want to do videos, if you want to do a walkthrough, that's fine. The second you identify or solve the problem that's holding us back, you let the rest of the mob know and you get back together. If at the end of your time boxed period, nobody's figured it out, you still get back together and you share what you've learned. Because it might just happen that people have uncovered enough parts of the puzzle that when you bring that all together, you can still move forward. So those are two approaches that we've used that have worked really, really effectively in this scenario. So what are we trying to do here? Well, we have this saying in our team, we're trying to default to collaboration. We've identified the benefits of mob programming, but we don't want to force that onto everything. So what we're going to do is, if we can't identify the best way of solving a problem, we're going to then tackle it in the most collaborative way. And if that's not working, so if mob probing is not working, then we're going to revert to pairing. If pairing is not working, then we're going to revert to working independently. But in general, we're going to default to collaboration. That's really the principle behind it. So, I work for a company that writes accounting software. And that means I'm surrounded by a lot of accountants. And just the other day, I mean, it must have been about a month ago, had an accountant, he saw us mobbing and he stopped us. He said, "Gentlemen, what on earth are you doing here? Because what I see you doing is you've taken the costs and you've just multiplied it by 3 or 4, because instead of doing one person's job, you've now got 4 people doing a single person's job. How can you motivate this?" I think it's really important that we can answer this question. We really have to understand, is this a cost-effective way of working? And so instead of looking at this from a cost perspective, I want to talk about it more from a productivity perspective. How do you measure developer productivity? Well, a former colleague of mine shared an experience that kind of polarizes the misconceptions we have with developer productivity. He was working on a project that was well behind schedule. And what happens when a project is behind schedule? Well, the project managers want more meetings to get updates. That makes a lot of sense. And he had the fortune to sit next to the project manager. And after one of the many status updates he had, he went back to his desk, was working on the problem, and the project manager looks at him and says, "Can you not just type faster?" In his mind, if we were faster typists, we were more productive developers. That's clearly wrong. Like, what we're doing is not typing. But how do you measure developer productivity? Is it number of hours worked? Is working more hours meaning that you're more productive? Is number of lines of code written? Well, I would love it if I was measured on productivity by number of lines of code written, because I know how to automate and solve that problem. How busy are we? Like, are we being productive if we're busy? What about time to market? Well, I think that's maybe a little more meaningful, right? If we get things to market a little quicker, maybe we're being a little more productive. What happens if we cut corners and we get to market really, really quickly, but with a subpar product? Maybe we're not being as productive as we can be. What if we measure financial return and worry about that, and that's an indicator of developer productivity? Well, again, I think that that's a little forward from how fast you type, but financial return is not just determined by developer productivity. For instance, I could write the perfect solution and a system could tank because it had poor sales or poor marketing, something totally out of my control. It turns out measuring developer productivity is really, really hard. So going back to Peter Block, he has this saying, he says, transformation comes from pursuing profound questions rather than seeking practical answers. And so instead of saying, how do we measure developer productivity, I want to change it around to ask, what impacts developer productivity? So I'm in a room full of developers here. Who has a pet peeve of what impacts their developer productivity? Yes. Meetings. Who? Meetings? Phone calls. Project disruptions. Project managers. People walking out. So I think there's a little context there. But I mean, that's maybe your situation. Yes.
People not making decisions fast enough.
Okay. So slow decisions from who?
Product owners.
Okay. Often I also find that they're just not available to make the decisions at the time that you need them.
Yeah.
And that can impact, because now you start waiting. Yes.
Coding the wrong thing.
Okay. Solving the wrong problem. Yep.
Working too many hours.
Too many hours. So you're putting the hours in. What happens if you burn the hours? Your quality of code goes down. You start wearing out. What happens when you write poor code? Well, that has an impact not only on your productivity, but on the productivity of any developer that comes and touches that code base after you. So I've put some of the common ones that I thought have impacted me and my development productivity. And they align to a lot of the things that you're saying. So multitasking, interruptions, technical debt, or code craft, just bad code, waiting for information, unnecessary meetings. My pet peeve, investigating defects, or even worse, investigating potential defects and then finding out after the investigation that it wasn't a defect. You just burnt days and days, or just not understanding the problem. These all impact developer productivity. I want to talk about how mob programming solves many of these problems. Let's talk about multitasking. We know that when we multitask, it can cost us, so if you're doing a switch in thoughts, it can cost you anywhere from 15 minutes plus. That's what studies show. You can imagine that multiple context switches within a day, you're losing potentially hours of your day just trying to get into the right focus. The practice of Kanban, like a fundamental concept of Kanban, is to reduce work in progress. And the reason this is the case is they understand that context switches are expensive. And so what they'll do in Kanban is you'll see that they'll write numbers up above each swim lane. And the idea is that you're not allowed to pull work items in that exceed that number. So if you're in planning, you can't have more than 3 items that you're working on in planning, or whatever number that you decide is appropriate for your team. In the team that I worked, we used Kanban for a very long time, and we really believed in limiting work in progress. And we would beat ourselves up when we broke that work in progress limit, yet we kept breaking that limit all the time. And eventually it just got so demoralizing that one day we threw away the work in progress limits. We were just like, well, we know that reducing work in progress is great, but we're battling. Shortly after that, we started mob programming. And I remember one day being in a daily stand-up and looking up at the board and suddenly realizing that our team of 6 or 7 developers was working on one thing. And that just blew my mind. We'd been chasing this number for years and never been able to achieve that. And then all of a sudden it just happened without even having that number there. And the realization I had that chasing the metric isn't what it's about. You've actually got to change your practices. If you change your practices, the numbers will follow. Mob programming solves a lot of context switches just because of the way you tackle it. Another one, defects, code craft, technical debt. What are these? Well, for me, essentially this is a question of quality. It's the quality of code written. So this is a graph that Llewellyn Falco has in his mob programming guidebook, which I recommend you getting your hands on. And he maps out what are the focus level, what is the quality of a developer during the day working on their own. And he's got peaks and troughs. And really what he's trying to illustrate is when you're working on your own, the best and the worst of you gets into all the code. Now we might try to retrofit practices to reduce that impact by code reviews or peer review, but essentially we're doing it after the fact. When we change it up and we have a group of people working together on code, only the best of us gets into the code. All the worst of us is filtered on the spot. And that means that quality soars. It absolutely soars. And that's been my experience with mob programming, is the quality of the code that you're writing is just so much more higher because you have that diversity in the mob, seeing things from different angles. Really, quality is a big, big thing for me. So does that mean if quality soars, costs decrease? Well, I think pretty much every study that I've seen and kind of empirical evidence for me is if you've got a solo developer to work on a problem and you measure the time that they started to the time that they got into production, and then you've got a group of developers working together and you measure the time that they started and the time that they get into production, and then you work out the hours that they work, every single time that solo developer will be faster than the mob. But if you're measuring costs just from the point of the time that you start to the point time that you get into production, you've missed the major costs in software development. Because the major costs are once it's in production and you pick up defects. And so only when you start looking at that time span do you start realizing that there's actually a compelling financial motivation for higher quality leading to cost reductions. So, well, that sounds great. Isn't this just a very expensive form of pair programming? I mean, in pair programming, I've got two people working together. I've got the worst getting filtered out all the time. The best is getting into the code. Why don't we just do pair programming? Well, I think there are a couple reasons that at least I can see. The first happens to be on ideal team size. So there were studies done by the American Psychological Association in 2006. And what they were trying to identify is what's the ideal team size to solve complex problems. And they did the study with just under 1,000 people. And they gave them varying problems to solve, knowing what their intellectual capacity was. And they came to the conclusion that when people work in twos, they can only solve problems up to the level of the cleverest person in that pair. So if you're in a group of two, you're only picking up things up to the cleverest person. As soon as they moved to groups 3 to 5, they found that groups are able to actually solve problems more complex than the cleverest person in the group. And so their recommendation was that we should be working in slightly larger groups than 2. That 3 to 5 is kind of their ideal size for them. And in my experience in mob programming is that's actually kind of the size that we tend to end up with. And that was even before I was aware of the study. That was just empirical evidence, what felt right to us. I think that there's a good argument that we can solve really, really complex problems with just decent developers. And we're solving much better problems than when we're working in twos. That's not the only reason I think mob programming is better than pair programming. So, what happens in pair programming if you work with a really, really strong personality and they feel that something's really right? I mean, in Terry's talk in the keynote today, she was speaking about some of the hot topics, Vim or Emacs. I mean, obviously it's Vim. Or what number do we start for months? 1 or 0 for January? Or if and else statements versus select and case statements. We like to get caught up in little things. That's kind of the passion that we bring to developing software. And the problem is that can actually hinder our progress. The beauty of when you go from a pair to a mob, you have this group majority, which means, yeah, like you might have a valid point, but as a group, we're going to make a decision. We're going to go where the majority wants to go. So we're not saying that you haven't convinced the group yet. And so a lot of the heated debates that happen in pair programming just fall away in mob programming because it's just not as confrontational. For me, that's a real benefit, especially since we have so many introverts in our industry. There is another benefit as well, which is this concept of increased flow. So when you're in a pair and your phone rings or you have to go to a meeting or you're sick, work stops. Like you're no longer in the pair. When you're in a mob and you have to go for a meeting, you just slide out. You go to the meeting, after it you come back, move into the typist role, and the work just follows. It just keeps going. The most important thing is always worked on by a mob. Flow just absolutely increases. For me, that's another real tangible benefit that I see from mob programming that I don't necessarily see in pair programming. So the last thing I want to talk about in terms of developer productivity is the concept of waiting for information. And we have a saying in mob programming which is, if we're not able to answer a question, then we're missing someone in the mob. The experience I had early on in mob programming was we were working in the banking sector in a fairly complex domain, and we had to book time with a domain expert. And traditionally, the way it would go is you would book some meeting time with this person. It would normally take a day to get into their calendar, so you're going to wait a day. Then you'd have the meeting with them. They would tell you what you need to know. Then you'd go tackle a problem. You'd realize, oh, I've missed something that I need to get. Now I've got to book more time into the calendar. What do I do while I wait? Do I do nothing, or do I start new work? If I start new work, now I've introduced a context switch. I've increased my work in progress limits. What's going on? So we tried to change our approach. We thought, instead of booking a meeting, we're just going to bring this person into the mob. We understand that they don't understand code. That's fine. We can translate it to them. We brought them in. We had an hour meeting at the mobbing station. We were all working. They gave us the initial feedback we needed, and then as we worked, we uncovered additional things that we hadn't identified, and they gave us feedback straight away. And at the end of that hour, we had pretty much solved the problem at hand. By the end of the day, that problem was in production. And that person was blown away. Something that had historically taken days, if not weeks, we had solved in hours. And for me, that's a real benefit of mob programming, is having that information accessible to you, just being able to work together on it. So the last thing I want to talk about, and this isn't necessarily with developer productivity, but this is more for adoption, and that is physical setup matters. You've got to have the right type of environment. Now this is a picture of a team based in the US. You'll see this is hunters. They do irrigation systems, and they've seen so many massive benefits from mob programming. They've now got 12 teams that mob. And if you Google mob programming, you'll see a video of these 12 teams working. It's just amazing to see. But if you look at their setup, they've got large screens. Everybody's got open space to work. They're feeling comfortable. That physical setup really, really matters to get this right. You don't want to be in an environment where people are cramped. So getting that balance right, be aware of it. And if you see some benefits in mob programming, you want to invest the money into getting the right equipment. I like to say the tail doesn't wag the dog. Like, we're here to produce great software. And if there's a better way of producing software, we're going to spend money to get that because of the competitive advantage that we get. So essentially, what is mob programming about? It's about people taking something and pushing it to its limits. And what really, really excites me about this industry is, what are we going to be doing in 10 years' time? Like, is bandwidth and VR going to get to a point where we can work effectively without having to be co-located? What are we going to do? And for me, that is the exciting thing about mob programming, is coming back in 10 years' time to see what we're doing then. So thank you very much for your time. I really appreciate you attending this session. I'm not sure how we're doing on time. Are we out of time?
37 minutes so far.
37, so I probably have time for 1 or 2 questions. Yes.
Mark, if you had an idea to develop a product now from scratch,
Yeah.
you cashed out your pension and you put everything on the line, you've got enough runway to accommodate 4 developers for 9 months, and you need to get the minimal viable product out.
Yeah.
How would you approach your SDLC? When would you mob? When would you pair? When would you go single, solo?
Okay, so the question is, if you're under real pressure, financial constraints, and your job is on the line or your livelihood is on the line, like, how would you determine what to do? The unfortunate situation is it's so context dependent. It really depends, like, what problem you're solving, what product you're getting out. I think that there's a compelling reason that increased quality has returns within days and weeks. And so, like, I would tend towards increasing quality. But getting that balance, that's the fun part. I don't think there's a hard answer for that. Yes, listen to that.
I'm curious about the sort of interpersonal issues that you might pick up in a mob programming situation. Like, how much of your day would you be spending in a mob, and how much would you be spending yourself? Not that I want to stereotype developers, but for some of us, it's still a big move forward not to be programming over stale pizza in our mom's basement.
Yeah. Okay, so how much time do you spend in a mob? Okay, so the things that we've learned, it's never a good idea to force people to work a certain way, right? If you do that, it doesn't matter what practice you're going to have, it's going to work really, really badly. So first of all, you need to have people to believe in this way of working and want to work that way. And then it's really up to them what is appropriate. In the team that I'm in now, we kind of start mobbing at about 10 o'clock. We go 10 to 12:30. We take lunch. We pick it up from the side to work on our own, because we found that we still have this need to spend some time on our own. And we also, like, if somebody doesn't want to be in the mob for the day because they have something else, that's fine. It's all about communication. But it's not unrealistic to work like this. We've done this for quite a long period of time and seen really, really good results from it. Yes.
So you mentioned just now that you never want to force an individual or a team to adopt a certain practice.
Yes.
But if you have a company that you decide, wow, this mob programming thing is really working for us, and at some point I want to get my 12 teams using mob programming, not everyone in that 12 team setup is going to want to do it.
Yeah.
So where does that leave you?
So that leaves you in a really tough space. Because what it means is you have individuals that are not wanting to work the way a group of people want to work. And while we want to respect autonomy, at some point those people are probably not going to be a good fit for that organization. They're probably going to move on. And for me, that's the beauty of it. Like, we don't want to force people to work a certain way, but we also want to work together and identify the best ways of working. So I'm aware that maybe there are a couple more questions. We've run out of time. Thank you very much for your attention. If you have questions,